Robyn, that's a good way to get started. Why don't you tell us a little bit about what Twin Lakes is like? What kind of a lake, or what kind of lakes are Twin Lakes?
Yeah. So the Twin Lakes are two small, very close together, deep lakes that are in Columbia County that drain into the Rojan watershed. They're about 30 acres in surface area with average depths around 30 feet, but maximum depths in excess of 80 feet. So these are probably the deepest lakes around the area, the deepest lakes that I'm aware of in Columbia and Dutchess County. And they might be the most, by volume, the largest lakes in the Rojan watershed. I don't know that for sure, but I suspect, given that those depths, that they probably are. These lakes have really limited inflows and outflows. There is a surface inflow into the North Lake and an outflow, but they're pretty small, especially relative to that large volume. And in the South Lake, there's no surface inflow at all that we've identified, and not a permanent one anyway, maybe some things that flow seasonally. And the outflow also only flows seasonally through a culvert pipe that most of the year is perched above the lake level. So this leads to a really long residence time in these lakes. It's hard to measure because of the how slow and intermittent these flows are. So I don't have a really definitive number, but I expect the residence time in these lakes to be on the order of decades. So that means what gets into the Twin Lakes has the potential to stay in there for a really long time, given the ratio of the volumes to the inflows and outflows of these systems.
So this project at Twin Lakes, where the neighbors, the people residing at the lakes got together, started a couple of years ago. Is that about right? Two,
Yep.
3 years ago?
Yeah, I started with them in 2018. They contacted, the folks at the South Lake contacted Hudsonia for a lake assessment. And because these were deep systems, Eric Kiviat asked me to get involved. He's more of a shallow, wetland system guy, and I'm a deep lake scientist. So I got involved with the assessment of the South Lake and found it to be a really great site for me to train my students in lake science. And so then, from there we branched out into the North Lake. And since then I've had several students up there doing all kinds of ecological and sort of more sociological research in these communities to bring data and do some community organizing to take some actions on that data that we've been collecting.
Yeah, it's never science alone. It's science in the community and the will to actually make some changes. So as you got started on this project, what did you see as the biggest problems in these lakes? What were you thinking of trying to address?
Yeah, well, the community was concerned with their own, they were concerned by what I call the greening of the lake. So they were noticing a lot more plant growth, a lot more, in the near shore areas, a lot more surface scums they were seeing, and some changes in the clarity of the water. So we've dug up a couple of historic reports that show that in the past, these lakes were quite clear, what we'd call blue water, low nutrient lakes, but over time they are getting greener and greener. So that was the concern that caused the community to seek some advice. And that is a concern. We call that process eutrophication, is that greening of lakes from excess nutrients, particularly nitrogen and phosphorus that come from human and animal waste and fertilizers and things like that. So the greening of the lakes is definitely a concern and something that is been underway for a long time and is quite hard to reverse. Since we've been studying the lakes, we've identified a few other issues. One is the increase in salinity, and particularly in the South Lake. So compared to the reports that we have on the South Lake from the 80s and the 90s, the salt levels in the South Lake have tripled. They're now in the range of, in conductivity, a 300 or so, 300 to 400 microsiemens per centimeter is the conductivity units. And we can anticipate seeing negative effects on aquatic biota at 500 microsiemens. So we're really getting to that level where the salt itself is gonna be problematic. And at this stage, it probably already is like shaping the community in some ways, as more salt tolerant species are able to have an advantage over the species that would prefer it not to be so salty.
Yeah, so you've gotten into this a little bit, but what kind of measurements have you been making other than the salt? And I think you've already discussed a little bit about what you've learned, but if there's anything not, yeah.
So we take vertical profiles with a YSI probe that go all the way down to 20 meters, so about 60 feet. So we don't get quite to the very bottom, but certainly down into the deep lower layer of the lake. And so we've been taking those depth profiles of temperature, oxygen, and conductivity. And so that gives us a baseline sense of what's going on with the lake dynamics. So these are lakes that we call seasonally stratified. So there's a cold, deep layer and then a warm upper layer. And it's like that all summer long. You know, if you've ever jumped into a deep lake, you feel that cold water on your toes, right? So that's a stable condition that persists all through the season. And so that these profiles help us see differences in both that physical structure of the lakes. The oxygen tells us where the algae are growing effectively and things like that. So we take these vertical profiles. We also use what's called a Secchi discs to measure the water clarity. So this is a really old tool. It's been used by lake scientists for over 100 years. It's just a black and white disc, and you lower it down into the water and you look to see where you can't distinguish the black triangles from the white triangles. And then that gives you a sense of your water clarity and how it's changing over time. So that's also, you know, an important measurement for tracking change in the lake. So we do those Secchi disc measurements. And then we take some water samples that are tested for fecal bacteria and turbidity.
So there's certainly some overlap with what we do in the Rojan. We also do conductivity, and we also use the YSI, although we never go below about 6 inches down.
Yeah, yeah.
It's flowing water. The last thing I'd like to talk a little bit about is something that's really sounds like fun. You've created rafts with floating plants to try to address some of the nutrient issues in the lakes. Can you talk about that a bit?
Yeah. So like I mentioned earlier, once your lake starts greening, it can be really hard to reverse that, especially in lakes that have long residence time like the Twin Lakes do. So the idea is that nutrients, these fertilizing nutrients, nitrogen and phosphorus, have been accumulating in these lakes, you know, for decades, really ever since those houses have gone in, because they're on septic systems, and just slowly over time, some of those nutrients from those septic systems are leached into the lake water. And over time, those nutrients accumulate, and then they're fertilizing the algae growth in the lake, which the algae growth and the plant growth, which gives you that greening and that thicker vegetation around the shores and so forth. So there's ways to treat the symptoms of the eutrophication, but it's really hard to get the root cause of it, right? So what we want is nutrients out. We wanted to create a mechanism by which we can remove nutrients from the lake and not just treat the symptoms of the eutrophication with chemicals, for example, or with aeration, which is not going to be effective in systems as deep as these. So those are some common techniques, right? So we were just looking to get at the root cause of the problem, which is nutrients in, by creating a way to get nutrients out. So we're growing plants hydroponically on floating platforms in the lake. And the idea is that the root structure from those plants is getting into the water. So all that plant growth on those floating platforms represents nutrients removed from the lake water, right? So it's kind of like creating a new competition for the algae for those nutrients by growing those plants. And then the plan is to harvest the tops of those plants at the end of the growing season, which we're coming up to pretty quickly. And I'm going to remove those biomass. We're going to attempt to overwinter the root structures of those plants in the hopes that we can resprout them next year. And the reason we're doing that is because we want those roots to grow longer and longer, because the deeper they get, the more they're getting at those nutrients that are stored down in those colder, deeper waters of the lake. So that's what we're after, is kind of creating a new nutrient sink in the form of these plants that we're growing hydroponically on the floating platforms.
That sounds like a lot of fun. And as I understand it, individual residents are taking charge of individual rafts and
Yep.
tending them and
it's still pretty small. I would expect that effect, the nutrients that we're taking up is still relatively small to the total supply available in the lakes, but you got to start somewhere.
Yeah, and over time,
And over time,
you expand, et
a
cetera.
sink is a sink, right? So
Yeah, it's going the right direction, and that's what we want. Great. I appreciate you taking the time, Robyn. I wish you could have been here in person, but maybe next time. Thanks
maybe
very
next
much.
time. Yeah. Thanks. I'm happy to join you by video and hopefully someday in person. Thank you.
That sounds great. Thanks, Robyn.